Okay, point 4.4, we're going to be factoring polynomials, especially those of higher degree than 2. So this is x cubed, this is 3y to the 5th. Okay, the first strategy is to look for a common factor and then see if you can factor the remaining in a different method. So if I look at A, x cubed, 4x squared, and 5x, they all have a common factor of x. So I'm going to factor out the x. If I take out x, I'm left with x squared minus 4x minus 5. And then I want to factor this into linear factors if possible. So I'm going to see if this will factor further. It's a quadratic, so I can probably do it in my head. So that's going to be x times x to get x squared. To get negative 5, it's got to be minus 5 and positive 1. Okay, and so since this was degree 3, I factored into 3 linear factors. Now let's look at B. 3 and 48. Can I divide? I can take out a 3 for sure. It's y to the 5th and y to the 3rd, so I can take out y to the 3rd without going over. Okay, if I take out 3y to the 3rd, what am I left with? Y to the 2nd, 3 times 16. Okay, and then again, if I can factor the part in parentheses I'm going to, it's a difference of squares. So it's y plus 4 and y minus 4. Okay, and then I factored this completely as far as I can. Let's look at C. Let's see, 5, 30, and 45. All divide by 5. Z to the 4th, z to the 3rd, and z squared. I can take out z squared. Okay, if I take out 5z squared, I'm left with z squared plus 6z plus 5 times 9. Okay, and then again, if I can factor the polynomial further, I will. What is this? Z plus 3 times z plus 3. Okay, this is a good answer like this. If you chose to write it like this as well, let me show you. You could also make this z plus 3 squared instead of writing z plus 3 out twice. It doesn't make a difference though. Let's look at D. M cubed, M squared, M. They all have an M, so I'm going to take out an M. Okay, go ahead and try D, E, and F on your own. I'll solve them while you're doing them. Okay, go ahead and check your answers for D, E, and F, and then we'll do the next strategy. Okay, for example 2, we're going to do what we call factoring by grouping. Some of you are familiar with this strategy because that's how you factor ax squared plus bx plus c. Okay, now factor by grouping often happens when you have 4 terms. Or at least you can try it when you have 4 terms. Okay, when you have 4 terms, you can split it into 2 groups of 2, and we're going to do a common factor for each one. So let's look at this first one here. I'm going to look at only the first 2 terms, and I want to take out the greatest common factor between 4x to the 3rd and 6x squared. Can I take out 4? No, but I can take out 2. I can also take out x to the 2nd. Okay, so that's going to be 2x to the 2nd times 2x, 2x to the 2nd times 3. And now I go to the second pair, the plus 10x and the plus 15. So I'm going to put plus 10 and 15. Do they divide by 10? No, but they divide by 5. Okay, so 5 times 2x is 10x, 5 times 3 is 15. Okay, this is the first step. Now from here, I want to check. If there is a common factor here and here, I can factor by grouping. Okay, since this is a common factor, the 2x plus 3 and the 2x plus 3, I can factor out the common factor of 2x plus 3, or I can pretend like I'm distributing something times 2x plus 3. So I'm multiplying 2x squared by 2x plus 3, and I'm multiplying 5 by 2x plus 3. So that's the same as saying I am multiplying 2x squared plus 5 times 2x plus 3. Okay, now let's look at this to see why this works. Okay, if I were to actually distribute this out, I would do 2x squared times 2x and times the 3. That's this part. And I would do plus 5 times the 2x times 3, which is this part. So this is exactly equivalent to this. If this would factor further, I would factor it further, but in this case, it does not. Okay, let's look at B, because this is very similar. Okay, there are 4 terms, so I'm going to group them into 2. So if I look at the first 2, can I take out a coefficient? No, but I can take out m squared times m plus 5. Okay, for the minus 4m and the minus 20, I'm going to take out a minus 4. I'm going to take, whatever this sign is, I'm going to bring it down. If I take out minus 4, that's minus 4 times m and minus 4 times 5. Okay, for grouping to work, these have to match. If they don't match, we'll have to do a different method, which we haven't learned yet, but we will soon. Okay, so I'm really doing m squared minus 4, and then I'm timesing it by m plus 5. Okay, now I want to glance here. If this will factor more, I am going to factor it more. M squared minus 4, oh yeah, that's a difference in square. So this is m plus 2 times m minus 2, and I'm timesing it by m plus 5. Okay, so this is a nice factor. I could take it the whole way out. Okay, if you think you've got the hang of it, go ahead and try the next ones on your own. If you don't, I'll try to work them out while you're working on them. Okay, so 3. Can I take out the 3? Yeah, 3z squared. 3z times z, 3z times 2. Okay, next one. Since it's a minus 7z, I'm going to take out a minus. Take out the 7. 7, negative 7 times z, negative 7 times negative 2. So what do I get there? I get 3z squared minus 7 times z minus 2. Now does this look like it can factor? No. So I'll leave it like this. And again, just glance. If I do n squared minus 3, it looks like a difference of squares, but I can't use a rational number to multiply by itself to get 3. Okay, next page. Okay, for E, I had x squared minus 4, and I could factor that into x plus 2x minus 2, so I did. X plus 2x minus 2 and x minus 7, and the order of your terms does not matter. Okay, what can I take out here? 4x squared times x plus 1. Okay, what am I take out? Minus 9 times x minus 9 times 1. Okay, now can I factor 4x squared minus 9? I know 4 is 2 times 2. This is 3 times 3, so I can do this. This is going to be 2x plus 3 and 2x minus 3. And then I can do x plus 1. Okay, we're going to do one more type of factoring. It's going to be a sum of cubes and a difference of cubes. Okay, if you have something of the form of a cubed plus b cubed, you might think it would be the quantity a plus b cubed, but we've multiplied that out before and we know we get a giant polynomial with 4 terms. So it has a pattern to it, and it will always follow this pattern. So in the first factor, it's a binomial, it's going to be a plus b. And it always matches. It's this plus this. Okay, now in the second parenthesis, in order to get the a cubed, this is always a squared. Now you don't really know why, but in order to cancel out all the pluses, there has to be a minus. So your minus sign is going to go next, and it's going to be a times b. That's the only minus sign, and then I'm going to do a plus sign. And then to get the b cubed, this has got to be b times b squared. Yeah, this is the pattern that it's going to follow. And you're just going to have to memorize it, to be honest. Okay, let's try it. Okay, so I'm going to look at A. A says n cubed plus 8. Now, if I can rewrite 8 as something cubed, we can follow this pattern here. Okay, so what do I cube to get 8? 2. Why is it 2? Because 2 times 2 is 4 times 2 is 8. So this is n cubed plus 2 cubed. So if I want to factor it, in the first parenthesis, I'm going to do the first thing plus the second thing. So in this thing, the first thing cubed is n, the next thing is 2. Let's look at the second parentheses, which is going to be a trinomial. Okay, to get the n cubed here, this is n times n squared. Okay, you don't know why, but in order to cancel, there has to be a minus, so the minus is going to go next. When I do the minus, I'm going to do a times b, which is the two things times together. So in this case, the two things are the 2 and the n. So 2 times n is 2n. And then I'm going to do a plus sign. And then there's two ways to think about this one. One is that I just take this last number and square it. So this is 2, and I square it, I get 4. Or sometimes I just go, okay, this has to be 8, so this must be 2 times 4. Okay, and then this is going to be my answer for as far factored as it can go. It feels like this should factor more, but to get 4, it would be 2 times 2, which adds up to 4, or it'd be 4 times 1, which adds up to 5. So it's never going to go further than that first step. Okay, now that you've seen it, let's look at B. Okay, it's x cubed plus, what can you cube to get 125? Well, it ends in 5, so it's going to be 5 cubed. Yeah, 5 times 5 is 25, times 5 again is going to be 125, which means the first parenthesis is going to be x plus 5. Okay, now the second parenthesis. Okay, to get x cubed, it's got to be x times x squared. Okay, there's going to be a minus sign because it has to cancel stuff out. What I minus is going to be the first thing times the second thing. So it's going to be x times 5, 5x. Okay, then there's a plus sign. In the last spot, I put the second thing squared. So 5 squared, which is 25. Or you could look at this and go, okay, 5 times this has to equal 125. So 5 times 25. This is my final answer. Again, the trinomial will not factor further. If you do 25, it's 5 times 5, which adds up to 10, or it's 25 times 1, which adds up to 26. So it's never going to go further than that. Okay, now that you're starting to get the hang of it, let's mess you up by adding a coefficient on the first term. Okay, this is 64p cubed plus 1. If I can make this something cubed, I can still do a sum of cubes. And since it looks like a sum of cubes, I want to try. What can you cube to get 64? 4 times 4 times 4. So this is going to be 4p, and that's what I'm cubing. Okay, what do I cube to get 1? Well, that's easy, that's 1 cubed. Okay, so the first parenthesis is going to be 4p plus 1. Okay, now I have to figure out the next part. Okay, now you can either follow the pattern or you can try to fill in the blanks. Okay, so this should be the first thing squared. So the first thing is 4p. If I do 4p squared, that's 4p times 4p, which is 16p squared. Okay, or you can look at this at the first thing here and say this times this has to equal that. 4p times 16p squared, that does equal to that. Okay, remember to cancel, there's got to be a minus. Okay, and then what I put there is the first thing times the second thing. So 4p times 1 is 4p. Okay, plus sign. Okay, in the last spot, I either put the last thing squared, so 1 squared is 1, or I can look and say, okay, this has to add into 1, so if I do 1 times 1, that gives me the 1 there. Okay, that's my factor. Again, the trinomial will never factor further. You will be tempted and it will just never do it. Okay, one more, and then we'll do difference. Okay, it looks like something cubed plus something, so I'm hoping it's something I can cube. Okay, we already did 8. 8 was 2 cubed, so this is 2m cubed. Okay, what do I cube to get 27? That's 3, because 3 times 3 is 9, times 3 is 27. So my first parenthesis is going to be 2m plus 3. Okay, figure out the next thing. Okay, you can either square the first thing. 2m squared is 2m times 2m, which is 4m squared, or I can say this times this has to give me this. So 2 times 4 is 8m squared. Okay, because it's going to cancel after minus. And I have to do the first thing times the second thing. So 2m times 3 is 6m. Okay, last spot. You can do the second thing squared, which is 3. 3 squared is 9. Or you can do 3 times this has to give me 27. So it's got to be 9. Okay, hopefully you're starting to get used to the pattern. Now, there's also what we call a difference of cubes. Sum means plus, difference is minus. So there's a pattern for difference of cubes as well. It's very similar. So once you know one, you'll be able to figure out the other one. So for the sum of cubes, it started with a plus b. Difference of cubes, we start with a minus b. Okay, since there's a minus here, we don't need to put any more minuses in this whole formula. Okay, it still starts with a squared, but it's going to be plus ab and plus b squared. So same pattern, it's just the signs move. There's always one negative sign. Okay, let's look at the first one. It's x cubed minus 27. So what do I cube to get 27? 3. Okay, so the first parentheses is going to be x minus 3. Okay, the second parentheses. Okay, first thing squared. So x squared. It's going to be a plus, because I already did the minus sign. Okay, a times b. So x times 3, 3x. Plus last thing squared, so 3 squared, 9. Or work it backwards and go, okay, this times this equals negative 27. And it actually has the right sign too. So it should work. Okay, that's the pattern. Let's try the next one. N cubed minus 64. What's 64? 4 cubed. And you'll start to recognize them the more you do them. So the first parenthesis, binomial n minus 4. Let's fill in the blank. Okay, to get n cubed, it's got to be n times n squared. Okay, I already used up the minus sign, so everything else is plus. Okay, this times this, 4n. Plus this times this has to give me that, so this must be 16, or I do the second thing and I square it. 4 squared is 16. Okay, let's try two that are a little more complicated, and then we are done with today. Okay, to get 8, that's 2 cubes. This is 2x. What do you cube to get 125? 5 cubed. Okay, so the first parenthesis, 2x minus 5. Sign matches. Let's fill in the blanks. Okay, pattern. You can either square the first thing, so 2x squared is 2x times 2x, which is 4x squared, or I can say, what do I times this by to get this? Either way, 4x squared. All right, already used the minus, and I know all pluses. Plus this times this, 2x times 5, 10x. Plus the second thing squared, which is 25. And just to check, if I do minus 5 times 25, I do get minus 125. Okay, last one. Okay, to get 27, 3, and hopefully you're starting to recognize them. To get 8, 2 cubed. First parenthesis, 3p minus 2. Okay, next parenthesis. First thing squared, 3p, 9p squared. And just check, this times this has to equal this. Okay, I already used up the minus, so let's do all pluses now. So 3p times 2, 6p. And then last thing squared, 2 squared is 4. And then just double check. If I do negative 2 times 4, I get negative 8, so it works.